China is planning to build a nuclear power plant on the edge of the Gobi Desert that would be the first in the world to use molten salt as the fuel carrier and coolant. It would also be the first to use the radioactive metallic element thorium as a fuel source instead of the uranium traditionally used in nuclear reactors. Dr. Mark Ho is the president of the Australian Nuclear Association and joins us now from Sydney. Good morning. Thanks for your company.
Good morning. Thanks for having me.
For starters, tell me, what is a thorium molten salt nuclear plant?
The thorium bit's a little bit of a misnomer. The thorium isn't really the fuel. The thorium is just the fertile material. You actually have to expose the thorium to a neutron flux in a reactor to produce uranium-233, and that's the actual fuel. So this technology was actually developed out of the US back in the 60s. And it's been picked up by the Chinese to bring nuclear power into the interior of China, where there's not a lot of running water. You can air cool these reactors because they operate at high temperatures.
And does that make them more efficient, particularly that air cooling mechanism?
Yeah, definitely. So if you're running a reactor at, say, 600 degrees C, and for the molten salt reactor, it's actually quite safe because it's not a pressurized water reactor. It's not pressurized at all. Then you can actually get the kind of 40% efficiency that you see out of a supercritical steam turbine, or what they call a Brayton cycle gas turbine. And that's a higher number than, say, 33% efficiency of a Rankine cycle steam turbine.
And are they used elsewhere? What do we know about them, how they operate and their safety?
There's an interesting story behind this, because the Americans were looking at all sorts of different advanced technologies in the 50s and 60s. So one of them was the molten salt reactor. And it was about 10 years ago, I think, that the Chinese embarked on this molten salt reactor journey, so to speak. They signed an MOU to gain access to a lot of that research. They put $1 billion into it, and through very kind of deliberate steps of R&D, they've got to the point where they've got still a prototype, 2 megawatt thermal, being built in the interior, as you said, in Mongolia. But then that has a plan to be basically commercialized and become a power plant. So there's not a lot of operating experience, but there's very, very well documented research from the US about molten salt reactors.
I guess then this will be really closely watched to see if it is a success and what the limitations or the challenges are.
Yeah, it'll be closely watched. But look, I mean, the nuclear is happening all around the world, as in terms of current builds and as well as advanced reactor builds. But there is going to be a step change with decarbonisation using nuclear power. We're seeing talks about 30% of all electricity generated from nuclear power in China and the US, maybe even north of that. So, yeah, nuclear is a big part of the decarbonised energy mix.
Well, and we are having that conversation, or starting to, here in Australia, about nuclear as part of the power mix. Do you see this particular design as something that might be applicable in Australia?
Yes, eventually. Of course, there's always going to be various hurdles. For example, the regulators might not be familiar with the molten salt reactor design. And so in the US, they are also thinking of molten salt reactors. For example, TerraPower, which is financed famously by Bill Gates, they have a molten salt design as well. But it's going to take a bit of time for the regulator to be comfortable with that type of design. But yeah, certainly we'll be seeing many, many more different advanced designs in terms of reactors around the world.
Dr. Mark Ho, thank you very much for your time this morning.
Thanks very much.